All right, in this video, we're going to take the quadratic formula to find x-intercepts of a quadratic. So quadratic formula we were introduced in the last video. Now we're going to use the quadratic formula. So first thing I want to do, I want to make sure I'm in standard form. I'm equal to 0. So that's how I find an x-intercept. And I write my formula. So this video is going to be kind of long, so I'm going to do my best to go through the process, but take a break if you need to. So I start with my formula. Next step is I'm going to substitute my A, my B, and my C value into it. So let's start that. The opposite of B. The opposite of B. So the opposite of negative 10 plus or minus the square root of negative 10 squared. Now remember, I want to make sure I square negative 10, so I want to put in parentheses, minus 4 times A was 4, times C was also 4. And I'm going to divide that whole thing by 2 times 4, or A, which was 4. All right, so now I'm going to simplify. I'm going to simplify. So let's go ahead, and the opposite of negative 10 is 10, plus or minus the square root of whatever that value is. So let's just simplify. So negative 10 times negative 10 is 100, minus 4 times 4 times 4 is 64. And I'm going to divide this whole thing by 8. All right, let's move down. 10 plus or minus the square root. So don't forget that square root. 100 minus 64 is 36. Divide the whole thing by 8. All right, we're still moving. I'm going to do this. The square root of 36 is 6. So I'm going to have 10 plus or minus 6 divided by 8. All right, so now we're looking at, from our discriminant was positive, which tells us we have 2 roots, or 2 x-intercepts. Here, this actually represents 2 problems, the plus problem and the minus problem. So we're just going to split that up. So I'm going to leave it here. I'm going to have 10 plus 6. So I'm going to use the plus first. Divide that by 8. That's equal to x. And then I'm going to do x equals 10 minus 6. And I'm going to divide that whole thing by 8. So on the first x-intercept will be 10 plus 6, which is 16. 16 divided by 8 is 2. 10 minus 6 is 4. 4 divided by 8 is 1/2. So that is an example of finding 2 x-intercepts for our quadratic using the quadratic formula. And you can see it's pretty detailed. It's not super complicated, but there are a lot of places to make mistakes, especially with our negatives. All right, let's look at our next one. We have x plus 2x minus 4 equals 0. Standard form, I like that, equal to 0. Good. So I start with my quadratic formula, and I've already taken the liberty of plugging in our values. So if you want to double check that, I would. All right. Here is a number 1 mistake students make with quadratic formula, so I included this problem for a reason. Negative 2 plus or minus 2 squared. Now, I'm going to use my radical. 2 squared is 4 minus. This subtraction comes from the quadratic formula, right? It's 4ac, so I need to subtract 4ac. Now, 4 times 1 is 4. 4 times negative 4 is negative 16. We're subtracting a negative here. We cannot mess this up. That's the same as adding a positive. Divide this whole thing by 2 times 1, which is 2. So that's a key. When you have that negative c or negative b and you're subtracting a negative, make sure you change it to adding a positive. All right, this simplifies here to be the negative 2 plus or minus. Now I need the square root of 4 plus 16, which is 20, divided by 2. All right, I have a positive discriminant, which means I have two solutions. This is not a perfect square though, so my answers are going to not be nice. They're going to be decimals at some or decimal x-intercepts. So let's go ahead and write it like this. We're going to go -2 plus the square root of 20. I'm going to keep it in that form, and I'm going to divide it by 2. And then my other one will be -2 minus negative, or excuse me, not -20, positive 20 divided by 2. So that's where we also need to be careful. Now I'm going to go to my calculator. Now when I go to my calculator, I want to make sure I'm doing the entire numerator and dividing that by 2. So I'm going to do -2 plus the square root of 20, divide that by 2, and that's going to give me an x value of 1.236. And we might put an approximate there because it's rounded. And then for our other value, x is about -3.236. And again, we had two intercepts because we had a positive discriminant. There they are. So that would be an example of when we would use an approximation for the x-intercept as a decimal. All right, hang in there. We got two more problems. They're a little quicker than before. So example 3. I started everything, so I have 9x squared plus 12x plus 4. I want that equal to 0. Quadratic formula, substitute the values in. Now, this gives me -12 plus or minus 144 minus 144, which is going to give me the square root of 0 divided by 18. Now, from our discriminant video, when we have a discriminant of 0, there's not really a plus square root of 0 and a minus square root of 0. So this is where we have one solution. So we don't use that. We're just using the -12 divided by 18. Because if I do -12 plus 0, I get -12. And if I do -12 minus 0, I get -12. So there's only one answer, and that answer is x equals -12 divided by 18, which equals -2/3. So there is my one solution. And of course, if we looked at two solutions and one solution, we'll look at no solution. Now this problem's a little tricky, so hopefully you've gotten to this point. Not in standard form. So what we need to do is we need to add 4 x's to get it over there. So that would give us 3x squared plus 4x plus 2. And I wrote it this way so that it was in standard form. All right. So once I have that, if I go to my quadratic formula, plug in my values, I end up with -4 plus or minus the square root of 16 minus 24 divided by 6. And you might already see the issue here. If I simplify this, I have -4 plus or minus the square root of -8 divided by 6. And I can't take the square root of -8. We have a discriminant that's negative, which means there are no solutions or no x-intercepts. So that was a long one. I know it's about going to be just under 10 minutes, but that's an example or examples of using the quadratic formula to find our x-intercepts. Hope this helps. Make sure you kind of look back and take your time with this and details.